All right, in section 4 of chapter 5, we're looking at finding the mean and standard deviation of events, and so these are binomial events, are unprepared for a surprise true-false test with 13 questions, and all of their answers are guesses. So find the mean and standard deviation. Well, there's some formulas that we have in our text. To find the mean of a binomial probability and the standard deviation. So, to do this, the sample size is n, 13, and the probability, if they're guesses, we would think that it would be a 50% chance. So the mean would be 13 times 50%. So the mean number of questions right would be 6.5. Standard deviation is n times p times q was the formula. So n times p, and then q is 1 minus p. So 1 minus p, so that's what q is, just 1 minus the probability of p. And this gives us a standard deviation of 1.8. What do we think? It's at least 9 correct answers. So they kind of give us like a range of rule of thumb, minimum, maximum value, so plus 2 standard deviations. So if we look at the problem, if I go up 2 standard deviations, that put me at a 10.1, I believe. So I don't think it would be unusual. It's within the range of usual values. So no, it would not be unusual. Looking at another question, just the setup again using these formulas. A gambler places a bet on the number 7 in roulette. He or she has a 1 in 38 probability of winning. Well, so here's the probability, and if somebody plays it 250 times, right? So here's our sample size, and there's a probability. We would just multiply those together. And then we could find the standard deviation by doing the square root of n times p times q to help us figure out if 0 wins and 250 would be unusual or not. So again, using those formulas that we have on page 223 in the book are going to be helpful. N times p and the square root of n times p times q.